All right, this is going to be a little short video on torque and directions. Directions and torque. Directions and torque. It gets a little confusing trying to figure out the pluses and the minuses. So let's just take a quick example. Let's take a very easy lever here. And let's just put a load down here. So this will be our load force, which will be the force of the gravity on this object. And let's just say it's 200 newtons, just for fun. We'll figure it all out. And then, of course, we want to lift this. So we want to put an effort force. We're going to have to push down here with our effort force, right? And so the effort is trying to make everything go this way, and the load is trying to make everything sort of go this way. And you can see that those are two opposite directions, right? The effort is counterclockwise, and the load is clockwise. Okay. Now, how do we put it together? Well, there's two ways to do it. We kind of cheat a little bit when we're doing physics sometimes because we take little shortcuts. But sometimes, I even make the mistake of taking a shortcut without realizing that students might not be aware of the shortcut. So let's do it sort of the grueling way. And what we normally do is we normally start off with an expression where we know that the effort torque is somehow going to be the same as the load torque. But what do we mean by the same? When we say it's the same, we obviously know that it's not the same direction because we just drew the arrows in opposite directions. So if we were to write this down, our friend math doesn't know about the opposite directions. It assumes that the equal sign means the same in every way. And so what we would have to do is we would have to tell the mathematics that one of these arrows is pointed in the opposite way. And one of the ways we can do that is by adding in a negative sign, right? We can say that the load force is the opposite direction of the effort force if we put a minus in here. And now it's a more precise statement. It actually says that the magnitudes or the amounts of these torques will be the same, but their directions will be opposite. So we're using a minus sign here, not so much to mean negative as down or left. We're using the minus sign to translate as the opposite direction. And when we do that, we will see that everything will kind of work out the way we expect it to, okay? Depending on what it is we're trying to solve for. Let me show you that this would be the effort force times the effort distance or displacement technically. Our little negative sign for opposite stays out front. And then of course we have the load force and the load distance like this. Now, if you look at our picture, what do we have? Well, we have a negative or downward effort force. So I'm going to put a minus sign in there for that. That number will be negative. We also have a distance from the fulcrum, but remember this fulcrum is in the middle. So this is a left distance. If we're talking about direction, it's a displacement to the left. So it will also have a minus sign associated with it. And you can see how those two minuses, when they're multiplied together, will make a plus. And that's why we consider counterclockwise torque. Right? See this arrow up here, right here? That's why we consider that to be a positive torque, because it's usually the result of two negative numbers. Now, on the other side, we have this minus out front here, because that tells us that whatever we're doing on this side, it's going to be the opposite direction. What is the load? Well, the load is a downward force of gravity. See, it's right here. It's pointing down. But over here, we have a positive D, or R in this case, right? The R is the displacement to the right. So this will be a positive number. And you can see from what I've written that this red minus sign is necessary to make it a true statement. Because when you multiply this, you get a plus. When you multiply this, you get a minus. And of course, those are not equal. A plus cannot equal a minus. But our red minus sign says a plus is equal to the opposite of a minus. And it sort of turns the whole side plus again. You see that? So by adding that in, we've allowed the math to understand that the two directions are different. And the math then, no matter which one of these things you're solving for, whether it's this one, this one, this one, or this one, the math, if you put this in to tell the math that, it will be smart enough to know to figure out whatever the sign should be. So for instance, if you were solving for the load force, this force right here, the answer would pop out negative. The math would know that because we've told the math specifically about the directions being opposite by adding that red minus sign. Okay, so you can kind of see how it works mathematically. But it's kind of complicated, isn't it? So what we sometimes do is we sometimes pretend to not worry about the direction. We just go, let's just say that these are equal. And what we really mean by that is the magnitudes are equal. And there is a mathematical way to actually say that. We don't use it in high school very often. You may have seen it, you may not. It's called the absolute value. And it basically is a sign like this. And what that does is it basically takes the positive value of what's inside these little lines. And it's sort of a fancy way of saying ignore the direction. Now, we don't have to write that because it's complicated for us. So what we can do is just write it like this, and just in our brains, remember that we're now talking about the magnitude only when we do this. When you do this, you don't worry about any minus plus signs at all. And so you just write Fe and Re and Fl and Rl. And you just put in the numbers without any minuses or pluses of any kind. You don't worry about clockwise or counterclockwise. You just put in the straight numbers for each of these with no minuses or pluses worried about. They're all plus, in other words. And then you will get a positive answer and a positive answer every time. But here's the catch. If you were solving for the load force, let's say this was your unknown, you would get an answer, load force, and something positive. But that doesn't mean that it's necessarily a positive force. You have to go back to your picture and see that it's a down force, right? So the picture is critically important. If you're going to do a magnitude-only solution, you need a picture to show that that force is down. And so you would have to sort of add that in at the end. You know, you would say that the load force is, let's say it's 200 newtons, and you would add the down, right, to describe it. Because this part, when you do this, the math doesn't know the secret. It doesn't know that this and this are opposite directions because we didn't tell it. So it can't tell us the proper direction for the answer. All it can tell us is how much it is. And we have to look at the picture to determine whether or not it was down or up, or in the case of these R's, left or right. So this is kind of an easier way to do it without worrying about negative numbers, but it's a less mathematical, mathematically sort of precise. It's kind of like a bad grammar, right? Actually, no, it's good grammar as long as you remember the condition that you have set by only looking at the magnitudes. But if you want to do it with all the little minuses and you really are fussy and you want to make sure that everything just works out at the end the way it should, then you have to follow this method and you have to tell the math that these two torques are in the opposite direction before you begin. And you do that by adding a minus sign. Notice that minus sign has nothing to do with the other minuses that we put in. That's why I drew it in red. It's separate. You still have to put the minus and pluses for the up and downs and left and rights, right? And then whatever happens at the end will always be the right answer, and it'll also be the right direction. But if that's confusing, do it this way, and then just look at the picture and see if it's down in your picture, or see if it's left, and make that statement at the end, right? You could say FL equals whatever number of newtons you've got, and then you can add down or left or something like that, so that you know what the actual direction would be. And those are the two sort of different ways that you can look at getting the direction right with torque, because it's a little bit tricky. You can do the formal, make the statement say they're the opposite with the negative sign added in, or you can do the magnitude only and just look at the picture to get the context of the question to show you which direction things are going.